Okay, let's move on to the next question. The next question is question number 10. Before we start, let's quickly revise a formula that we've done in class 9, which means if you have a body with uniform cross section, if you need to calculate the volume of that body, it will be equal to the area of the cross section multiplied with the length or the height, depending upon how you keep it, horizontally or vertically. And next is, if you want to calculate the surface area of that body with uniform cross section, it will be equal to perimeter of the cross section multiplied with length. Here the surface area does not include the area of the cross section. Perfect. Now let's look at this question and see how we can apply this. It says cross section of a railway tunnel is in the form of a rectangle 6 meter broad and 8 meter high, surmounted by a semicircle. So this is also 6 meter, which means the radius of this is 6 upon 2, which is equal to 3. So the radius is 3. Tunnel is 35 meter long. Find the cost of plastering. So point number 1, radius of semicircle is equal to 6 upon 2, which is 3 meter. Number 2, we need to calculate the surface area. That's why we will need to figure out the that's how we'll figure out the cost of plastering it. So perimeter of cross section would be equal to this line, which is 6 meter, plus this part. No, this is not 6, this is 8, my mistake. The 6 is this, my mistake. This is 8, right? So 8 meter, this is one wall, the other wall, which is again 8 meter. So this is 8 meter plus 8 meter. This obviously is not there. This is not the ceiling. This semicircular thing is the ceiling of the tunnel. So plus circumference of semicircle. Right, so circumference of semicircle is 2 pi r upon 2. So this will be 16 plus pi r upon 2, will be 22 upon 7 into 3. Yes, so 16 plus 22 into 3, that's 66. So 66 into 66 upon 7. So this would be 7 into 16, that's 70, and 42, that's 112. Plus 66 upon 7, which is equal to 178 upon 7 meter, no y square, meter. This is the perimeter. Okay. Next part says surface area of tunnel would be equal to perimeter of cross section multiplied with length. So this would be 178 upon 7 into length, which is 35 meter square. 7 into 1, 7 into 5, that's 178 into 5, 500, 350, 850 and 40. So that's 890 meter square. Next part is simple. 1 meter square costs rupees 2.25. Therefore, 890 meter square will cost 890 into rupees 2.25. Let's multiply. This is 225 multiplied with 89. 5 into 9, 45. 18 plus 4, 22. 18 plus 2, 20. 5 into 8, 40. 8 into 2, 16 plus 4, 20. 16 plus 2, 18. That's 52002. So this is equal to rupees 2002.50. Remember to write the answer with 2 decimal places for money. Let's look at the next question. The next question that we do is question number 11. Question number 11 says horizontal cross section of a water tank is in the shape of a rectangle with semicircle at one end. A similar question. This side is 7 and the radius would be 7 upon 2. The water is 2.4 meter deep in the tank. Calculate volume. So number 1, volume will be equal to area of cross section multiplied with length. And next, let's calculate area of cross section. So area of cross section would be equal to area of the rectangular part, which is 21 into 7, plus area of this semicircle, which is pi r square upon 2. Yes, area of a circle is pi r square, which means this will be pi r square upon 2. So that's 22 upon 7 r square, that's 7 by 2 into 7 by 2, and pi r square upon 2. That's 7 and 7 gets cancelled, 2, 1, 2, 11. So this is 147 plus 11 into 7, that's 77 upon 4. Yeah, that's meter square. 4 into 147, 400, 160, that's 560, and 28, that's 588 plus 77 upon 4 meter square. This will be equal to 650, 665. 665 upon 4 meter square. Number 3, we need to calculate the volume. So volume will be equal to area of cross section, which is what we calculated, 665 upon 4 into the length, which is 2.5, and the unit is meter cube. 4 into 1, 4 into 0.6. Now we need to multiply 665 into 6, 6 into 5, 30, 39, 36 plus 3, 39, 36 plus 3, 39. So that's 3990, one decimal, so that's 399. So this is 399 meter cube. So that's the volume. Next, calculate the volume in gallons. So we need to convert meter cube into gallon, but the conversion is given as gallon with liter. So let's convert meter cube into liter first. So 1 meter cube is equal to 1000 liters. Therefore, 399 meter cube is equal to 399 into 1000 liters. Next, our conversion is from liters into gallon. So 4.5 liters is equal to 1 gallon. Therefore, 399 into 1000 liters would be equal to 399 into 1000 upon 4.5. 4.5, let's multiply it with 10 and let's remove this decimal. That's 5 into 9, 5 into 2, 3 into 3, that's 3 into 1, 3, 3. So this is 266 with 3 zeros upon 3 gallons. Let's divide 3 into 8, 24, 3 into 8, 24, 3 into 6, 18, 6 again, and 0.67 gallons. So that's the answer, 88,666.67 gallons. Let's look at the next question. The next question that we do is question number 12. Let me just open that file. Here, it says figure shows cross section of a water channel consisting of a rectangle and a semicircle. Again, a similar question. So this length is 21, which means the radius is 21 upon 2. Assume that the channel is always full. Find the volume of water discharged through it in 1 minute if water is flowing at a rate of 20 centimeter per second. Now, what does it mean? Till now we knew that volume is equal to area of cross section into length. So what we need to figure out is the length of this channel. So assuming that the diagram the picture that I put below, which is basically this is the channel that we're talking about. Let's say it says 20 centimeter of it gets emptied, or 20 centimeter of water which is contained in 20 centimeter of this channel flows out in 1 second. So if this is 20 centimeter, water contained in this much part of the tube gets out in 1 second. How long do they want to check? They want to check for 1 minute, which means this is 1 second, which means in 60 seconds, how much of it will go out? That will basically be the length of the channel that we're looking at. So point number 1, 1 second, 20 centimeter of channel flows out. Therefore, in 1 minute, which is 60 seconds, 60 into 20 centimeter of channel will flow out. So the length we have is 1200 centimeter. So if the channel was 1200 centimeter long, that's what they want us to calculate. Next, now let's again calculate the area of cross section. So area of cross section would be equal to length into breadth for the rectangular part. Length into breadth, that's 21 into 7 plus the area of the cross section, which is again pi r square upon 2. So that's half into pi into r square. R is 21 upon 2 multiplied with 21 upon 2. This is 2 into 11, 7 into 1, 7 into 3. Yes, there is nothing else that we can do. So this is 21 into 7, 147 plus in the denominator I have 4, and this is 11, that's 33 into 21. So 21, 33, 3, 6, 3, 6, 396. So 693. So again, this is 588 plus 693 upon 4 meter or centimeter square. So 693 and 588, 8 plus 3, 11, 10 and 18, 11 and 12. So this is 1281 upon 4 centimeter square. Number 3, therefore volume would be equal to length, area of cross section, which is 1281 upon 4 into length, which is 1200 centimeter cube. 4 into 1, 4 into 300, so that's 1281 into 300. So that's 1281 into 3, 3 into 8, 24, 6 plus 2, 8, 3. So this is 3843 with 2 zeros centimeter cube. 3,84,300 centimeter cube. If they want the answer in cubic meter and correct up to one place of decimal, to convert centimeter into meter, I divide by 100, which is 10 to the power 2, which means I will have to divide this by 10 to the power 6 to convert this into meter cube. That's 246 meter cube. 1, 2, 3, 4, 5, 6. This is 0.3843 meter cube. They want the answer up to one place of decimal, which means 0.4 meter cube. That's the final answer. Let's look at the last question of this exercise. Why the last question? Because the other questions have been deleted because hemisphere and semi-hemisphere are not in your syllabus this year. So question 5, question number 14 and 15 are not in your syllabus this year. Good. Let's look at this question. This question says open a cylindrical vessel of internal diameter 7, height 8. So this height here is 8. This diameter is given as 7, which means the radius is 7 by 2. Stands on horizontal table. Inside this is placed a solid metallic cone, diameter of whose base is 3.5 centimeter, which means the radius here is 7 by 2 divided by 2, which means 7 by 4. The diameter is 7 by 2, which means the radius is 7 by 4. And the height for this is also 8 centimeter. Find the volume of water required to fill this vessel. Done. Let's look at this. So volume to fill vessel would be equal to volume of cylinder minus volume of cone. Let's substitute values. Volume of cylinder is pi r square h. In this case 22 by 7 into r. R for the cylinder is 7 by 2 multiplied with 7 by 2 multiplied with height, which is 8, minus volume of cone is 1 by 3 pi r square h. Pi r in this case is 7 by 4. 7 by 4 into h is 8. That's 7 and 7 gets cancelled. 2, 4, 2, 2. So that's 22 into 14. 22 into 14 minus 7 and 7 gets cancelled. 4 into 2 to 1 to 2 to 1 to 11. That's 11 and 7, and in the denominator is 3. Yeah, so that's 77 upon 3, and the units are centimeter cube. 22 into 14, that 308. Yes, that's 308. 308 minus 77 upon 3, which is 924 minus 77 upon 3, which is equal to 850 minus 3. That's 847 upon 3 centimeter cube. Let's write this in decimal. So this is 3 into 2, 6, 8, 2.33 centimeter cube. So that's the volume required to fill this cylinder. Let's read the second part of the question. The second part of the question says, if this cone is replaced by another cone. Okay, so let's say we have a smaller cone now. Is it smaller? Yeah, it can't be bigger than this. The height can't be bigger than this. Replaced by another cone whose height is 7 by 4. So the height is 7 by 4 and the radius is 2 centimeter. The radius is bigger than the previous one. The radius is 2 centimeter. Find the drop in water level. So since we are not adding any water, which means let's say that this is the new level of water. Earlier the water was spilled right till the top. Now let's say this is the new water level. Right, this is the new water level, which means this part is empty now. There is no water. Obviously the cone is not there. So this part is empty. We need to figure out the drop in water level. Let this height be h. Right. So let the drop in water level equal to h centimeter. Next, again, I hope you realize that this is a mini cylinder that is being formed, and we can figure out the volume of this mini cylinder by figuring out the difference of the volume of the bigger cone minus volume of the smaller cone, because no water has been added. The only difference is the bigger cone minus volume of smaller cone. So let's just write that down. Difference of, or rather, yeah, difference in volume of the two cones would be equal to, this was 77 by 3 centimeter cube, that was the volume of the original cone, and let's calculate the volume of the new cone. So that will be 1 by 3 pi, that's 22 by 7 into r. R in this case is 7 by 4, no, the r is 2, sorry, r is 2, and the height is 7 by 4. That's 7 and 7 gets cancelled. 2, 2, 2, 1, 2, 1. That's 22 by 3. So 77 by 3 minus 22 upon 3, which is equal to 55 upon 3 centimeter cube. So basically, the volume of this part is 55 upon 3 centimeter cube. So the volume of this mini cylinder is 55 upon 3 centimeter cube, which means pi r square small h is equal to 55 upon 3 centimeter cube. Let's substitute values. H would be equal to 55 upon 3 into 7. Yeah, 55 upon 3 into 7 divided by r. R in this case is 2 into 2 multiplied with, so pi r square, that's 5 into 11. Where did I get the 11 from? That's 22, not 11, 22. Let's just confirm. Maybe I got confused. That's 22 upon 7 into r, 2 into 2 into h. This is fine. My calculation is correct. 2 into 2 into 22. So 11 into 2, 11 into 5. And we have 35 upon 2, 4, 8, 24. Anything else which can get cancelled? 5 into I think I've made some mistake. Let me just redo this last step. I think I've made some mistake. Okay, let's just redo this last step. Okay, so pi r square h is equal to 55 upon 3. 22 upon 7 into r is 2 into 2 into h is equal to that's the mistake. R is not of this cone, R is of the cylinder. That's the mistake. Yeah, too many radius, so I got confused. So let's just check. The R is of the cylinder, so pi r square h is equal to 55 upon 3. That's 22 upon 7 into r of the cylinder is 7 upon 2 multiplied with 7 upon 2 into h we need to calculate is equal to 55 upon 3. 7 and 7 gets cancelled to 1 to 11. H would be equal to 55 into 2 upon 3 into 7 into 11. 11 1, 11 5. Therefore, H is equal to 10 upon 21 centimeter. Pardon my confusion right at the last step. I hope the logic was clear to you. This is a mini cylinder that we're looking at, and the radius we should be looking at is the radius of the cylinder. That brings me to an end of this video. Take care, be safe. I'll see you with the next video. Bye bye.